So, what is inference? Welcome to the new section. We are going to be dealing with inference from here until the end. Alright, actually, from here until the end. So, we've kind of got to get a grasp of exactly what inference is now. I know I've talked about it this year already, but we're done with the probability. We're done with linear regression lines. Now we're going to get into inference, which you will have to do some z-scores and all that kind of fun stuff along with it. But what is it? Alright, so inference is taking a sample and taking that sample of something and then applying it to the whole population. So, for instance, when they're trying to project who's going to win the elections, next, they take a sample of people and then they poll them, and they say, all right, we're pretty sure just from this poll that the rest of the country will vote this way, right? And so we're not sure the whole country is going to vote that way, but we're pretty sure because we've met some different situations. Now, we're going to talk about some situations we need to make sure we check off our list in this whole chapter. Really, Chapter 7 is all about the rules. All right, Chapter 8 and 9, we start doing fun stuff with math. But Chapter 7 is basically all the rules behind how we can actually perform inference and making sure our inferences are on target. Okay? We want them on target and not like off. Okay? So, inference. Taking a sample and applying it to the whole population. Okay? Does that make sense? Cool. Alright, here we go. Some verbiage you guys wanted to make sure you got down. A parameter. Parameter is the data for the entire population. Alright? So for instance, I've given a situation. The average grade in this class is an 83%. Okay? So that is a parameter. That is everybody in the class. Right? Okay? The parameter would be everybody, right? Okay. The average attendance or unexcused absences for Craig High School is, I don't know, what do we say? It was like 30 or something like that. That would be the average unexcused. That would be everybody at Craig, right? Okay. So the parameter is everybody. In our case of voting, it would be the official vote. Like all the people who voted. This is how they voted, right? But then we have this thing. You guys probably never heard of this word before. Here, it's coming up. It's called a statistic, and that's what our book is named after, ladies and gentlemen. Our statistic is a number, but it only applies to the sample. Now, you probably didn't know that, did you? Okay, all right. So now you can go home today and say, hey, I learned what a statistic actually was. It is the number we get from a sample. All right. So for in situation, the average grade in America from our sample of 2,000 students is 53. Okay, percent. So is this everybody in America? No, it's just from 20,000 students. Right. So it's not everybody in America, just those 20,000. All right. Now, we might be able to say, the population is probably somewhere around there, the overall in America. But our statistic is just a sample. Okay, so we're going to go over some key verbiage, key symbols, just to make sure you guys are aware. I try to go over this about every chapter. Okay, signs and statistics, okay, and you will get more. Okay, population, you guys ready? So, what is our population symbol for mean? If we want to have all the data for everybody, it should look like this, right? Whoa, holy moly, that was a bad mean. Mu. It's mu, alright? That's Greek, alright? What's our sample mean? Well, you should say, if it's only from a sample, we're not exactly sure about it. So we make it an X, and he goes to the bar a lot, right? X bar, gotcha. Okay. Standard deviation, population. If we know the true standard deviation, we mark it as sigma. Little s. That's what Greek and s looks like that. It's sigma. And our sample standard deviation we write as S, just plain old S. Error. Is it Arabic? No, I don't remember what we call it. Okay? And then proportion. How do we list a proportion? I remember proportion is the same thing as, we like to think of it as like percent, right? A proportion. So how do we mark this? Well, we mark it with a big, gigantic P. Now some books, I'm glad they don't. It's too many people get confused. Some books in statistics, they use this symbol. Cool thought process here, right? They use that symbol for proportion, which kind of goes along with, notice our population is all Greek symbols until we get to proportion, right? Some books use this to mean a proportion. And that is the Greek letter for P. Just like standard deviation, that's the Greek letter for S, and this is the Greek letter for M. Alright? Some use this symbol, which we all call pi, as the letter P. Now, granted, it doesn't mean 3.14 in statistics. It just means your proportion. But AP Stats uses it like that. All right. Okay, and proportion, small. If we don't know the true proportion, if it's just a guess, oh man, I saw this many people, bring their book to class. I didn't check everybody. We're going to go P hat. Okay? So we like to put the little Chinese hat on them. P hat. Cool. You guys got it all? Sweet. Alright, how can we be accurate? Alright, how can a sample be accurate? By the way, there's like no math. You guys are just going to have to sit, ears open. This is probably the toughest test too. Chapter 7. I have people just flunk this baby. Just flunk it. Because they don't completely understand everything. So you got to listen. If you miss a day, make sure you ask questions. And watch these videos. How can X be accurate estimate of mu? Alright? Well, yeah, if we take one guess, we might be off a little bit, right? We might be slightly off. We're going to get into this. What would happen if we took a sample and we might be off slightly? But we take another sample and that one might be a little under. We take another sample and that one might be a little over. You know what all these samples will do? If we do all these samples, it'll always go above and below the actual amount, and thus making a curve. Alright, so I have a little project that we did in class. If you missed it, oh, too bad. It was awesome. Basically, everybody reaches into a bag full of 200 pieces of paper. They pull out 20, and they record what's the probability they got red. Alright, I call it red versus blue. Alright, now let's say somebody might have only gotten 40% red, right? So they come up and they plot a dot here, right? And somebody might have gotten 50% red, alright? Somebody might have even gotten here, right? Down here at 35, and some people got like 55. And let's just, anyway, so they all come up, everybody counts up how many reds they have, right? And they start plotting, and there's kind of a cool thing that starts to happen. As everybody starts plotting their data out, some weirdo goes there, right? Okay? And as they keep plotting their stuff, look what happens, right? These are tons of little samples, right? Each dot represents what a different kid had. All of a sudden you start getting this thing that almost looks kind of normal, don't you? Oh! What? It's a normal curve built on samples. Okay, so I'm kind of getting ahead of myself. This is called a sampling curve because it's a curve made of samples. We call it not just a sample curve. A sample curve would be like one person's, all their data, right? That's a sample curve. If you put a little I and G on the end of it, it's called sampling, right? Sampling distribution would be always something could happen, right? Okay, now I just realized I'm going to need a calculator in a second, and I think somebody might have taken it. I don't know if I got a calculator. We'll have to see. We'll have to pause it. But that's kind of how it looks, and it's kind of cool how this works. All right. Now, I have a video. It's a minute and a half. Maybe I'll post that on my classroom site. You guys can watch my loveliness explain sampling curves even a little bit more better. But let's see, how many ways could I do this? All right, so I'm going to go grab my calculator. Just a second. Bye. All right, so I'm back. I got my calculator. Now, oh, I also got some pop too, but you know, whatever. Little Dr. Pepper cherry today. Using our combination, how many different ways? So how many different, let's see, how many different samples could I put under a curve, right? How many different ways, how many different dots are there? Like, how many ways can I collect a sample? So basically, how many ways can I collect 20 cards out of 200? Well, if I do that in my calculator, remember you'd go like the 200. I'm going to run out of time. I just know it. Oh, well, we'll pick up tomorrow. 200 combination 20. If I put that in my calculator, I get this 1.61, and then we'll just say times 10 to the 27th power. Now, if any of you guys know scientific notation, that's a massive number. There is basically a 1 with 27 zeros after it, ways that I could select different cards in there, right? Holy moly. Okay, so how many different dots are there under this curve? Whew. There's that many ways it could happen, right? I don't even know what the number would be. There's that many dots that could form underneath this curve. Now, we only got like 12 or 20, depending on our class, ways that it could happen, but there's a ton of ways it could happen. Okay. By the way, we always put the cards back into the bag before somebody else pulled 20 more out, right? Because otherwise we keep doing that. All right. So this is called the sampling. All right. ING, not just a sample. It's called the sampling dis. All right, it's sampling distribution for crying out loud. You can figure out the spelling down there. Okay, I'm running low on time. Is all the ways an event could happen. All the ways, all of them. Okay. Now there's a lot of questions that deal with, you know, is this all the ways this could happen? And they only show like 20 or something like that. Odds are no. Just say no, that's not correct, because there's like tons more different ways that it could happen. But sampling distribution shows you all the ways. So is this technically a sampling distribution here? No, it's just 20 or however many dots I have here. It's only that many, right? There's technically, you know, that one with 27 zeros after it. That's technically the sampling distribution, that many dots. Okay, I'm not going to graph that out for you today. Okay, maybe in another video. Okay, so if our sampling distribution is unbiased, all right, which how do we do unbiased? Well, we take a simple random sample, right? If we take a simple random sample, we will not be unbiased. We will hit, right? We're not going to do any of those convenience things, right? Oh, yeah, I'm going to show up and just pick the first 10 people, right? This is where, you know, sometimes I think those polling things where they say, this person is going to win, because they're like doing, I don't know how they go about getting the data. It's like the people who answer the phone or something, that's biased, right? So it's not always going to be accurate. But if you get unbiased, then our P, right, our actual P, the actual P for whatever we're trying to find, so in our situation, how many red are in the bag, our actual P is actually the mean of all the little p's. Does that make sense? So if we took all of our little samples together, the center of that sampling distribution is exactly where the true amount is. So in our bag, guess how many are in our bag? Right? Well, this isn't the whole sampling distribution, but the center of our samples, definitely look at it, it's like it's at 50. Right? The mean of our samples, remember this is the symbol for sample. The mean of our samples is right there. So hey, guess what our P probably is? Our P is probably there at 50% too. So I'm guessing there's 50% red, which means is there 200 cards? So I bet you there's 100 red. And by the way, there's 100 red in the bag. Okay, we're getting close to being done. So here, this is the first thing that you guys got to memorize. All right, we're going to end here. But the very first thing you got to memorize, there's 6 things with proportions and means. Why do we do a random test? Here it is. You can pause it, Write it down. You can find this on my classroom. Goodbye.